Today we're going to talk about one-step equations with rational coefficients. Rational coefficients are the fraction, decimal, or integer multiplied to the variable. So when we are solving one-step equations, your goal is to isolate the variable. When you isolate the variable, that means you have to do the inverse. You want to undo what is being done to the variable. The golden rule here, when you are solving one-step equations, is what you do to one side of the equal sign you must do to the other. Remember, your goal is get the variable by itself. Isolate the variable. Usually, I like to get the variable on the left and the constants on the right. And how do you do this? By using the golden rule. What you do to one side of the equal sign, you have to do to the other side of the equal sign. So let's look at some examples, and we're going to just talk about this as we go along. So the first example I have is 4.2x equals negative 52.5. And if you forgot, coefficient is the number being multiplied to the variable. On the right side, we have our process. Ask yourself this question. What is being done to the variable? And I like to put a little line down the middle, separate the left side of the equal sign from the right side of the equal sign. Ask yourself this question. What is being done to the variable? The variable is x. So that's our variable. Our variable is x. What is happening between the 4.2 and the x? Multiplication. .2 is being multiplied to the x. So how do you undo multiplication? You undo multiplication with division. So we are going to divide by 4.2 to get x by itself. To get 4.2 away from x, you have to do the opposite of multiplication. Inverse, we're going to divide. Back to our golden rule. What you do to one side, you must do to the other. So if I am dividing by 4.2 on the left side of the equal sign, then I have to divide by 4.2 on the right side of the equal sign. So calculate negative 52.5 divided by 4.2. 4.2 divided by 4.2, this cancels out to become a positive 1. So that just leaves you with x. And the reason why I don't write the positive 1 is because it's a windy 1. You don't have to write it. It's a positive 1. Now I'm going to divide negative 52.5 divided by 4.2, and that leaves me with negative 12.5. We've learned about substitution. I'm going to plug this back into the original. 4.2 times negative 12.5. I'm just checking my answer. And what do you know? Negative 52.5. So that means my answer is correct. You can easily check your answer by simply plugging the value back in. Let's look at example B. I have m minus 7 equals 4. Ask yourself, look over at your process and ask yourself this question every time. What is being done to the variable? So I'm looking at my variable. First, identify your variable. My variable here is M. What is being done to the M? 7 is being subtracted. And we're using subtraction. You want to undo the subtraction with addition. That is the inverse. So I'm going to draw my line, keep my paper organized, and then add 7 to cancel out. So my variable will be by itself. Remember the golden rule. What you do to one side, you must do to the other side of the equal sign. So if I add 7 over here, I have to add 7 over here. I have to do that to both sides of the equal sign. Negative 7 plus 7, that cancels. That becomes a 0, but you don't have to write the 0. Bring the M down and then add 4 plus 7. It's 11. So your final answer here is 11. And you can easily check your answer by taking that 11 and plugging it back in for M. So instead of saying M minus 7, 11 minus 7 equals 4. That checks out. Example C. 5 plus y equals negative 10. Again, ask yourself the question, what is being done to the variable? Identify your variable. My variable is y. And what is happening to the y? Well, I have a 5 being added. I have a positive 5. So I'm going to put addition. You want to undo the addition with the inverse. What is the inverse of addition? Subtraction. Draw my line down the equal sign. And I need to undo what is being done. So I have to subtract 5. 5 is positive, and I need a negative 5 to cancel it out. Back to the golden rule. What you do to one side, you have to do to the other side of the equal sign. So if I subtract 5 on the left side, I have to subtract 5 on the right side of the equal sign. I'm going to cancel that and bring down my y, bring down my equal sign. Negative 10 minus 5. Calculate. Negative 10 minus 5. What did you get? Negative 15. And again, you can check this answer by plugging negative 15 back in for y. 5 plus negative 15. You should have gotten negative 10. That checks out. Negative 10 and negative 10. That's how I know that my answer is correct. Example D. Notice this one is written a little differently. All of my examples, I've had my expression on the left side and my constant on the right, or my solution on the right. On example D, I have my solution on the left side and my expression on the right. You still solve the same way. Identify the variable. Ask yourself the same question. What is being done to the variable? The 4 is being multiplied. So there's multiplication happening here. Undo the multiplication. With division. So again, I'm going to draw my line down my equal sign and The 4 is being multiplied to the x, so I'm going to divide by 4. Golden rule again. What you do to one side, you have to do to the other. So if I divide one side by 4, then I have to divide the other side by 4. Calculate negative 20 divided by 4, and I end up with negative 5 equals x. And again, you can plug in that 4 times negative 5, and that gives you negative 20, which means my answer is correct. Turn your paper over. We are on the back side. There's just a couple examples back here. We're going to follow the same pattern. Ask what is being done to the variable, and then undo what is being done to the variables. Example E. I have x divided by 3 equals negative 11. What is being done to the variable? Okay, first identify your variable. That's x. X is being divided by 3. So that means division is being done to the variable. Undo the division with multiplication. Let's look at this. I'm still going to draw a line down my equal sign, and I'm still going to follow the same golden rule. What you do to one side, you must do to the other. So if the x is being divided by 3, the inverse of division is multiplication. So I have to multiply by 3. If I multiply by 3 on the left side, I have to multiply by 3 on the right side. So that leaves me with x equals negative 11 times 3, which is negative 33. And again, you can plug it in and check it. Negative 33 divided by 3. Type that into your calculator or do it in your head, and you should get negative 11. So that does check out. Let's look at example F. In example F, we have 1/4 y equals negative 8. This is what we call a special case. Why is this considered a special case? Because the variable y is being multiplied by a fraction. So here, when we ask what is being done to the variable, it is being multiplied by a fraction. And when you multiply by a fraction, the only way to undo multiplication by a fraction is you have to multiply by the reciprocal of that fraction. Flip the fraction. I'm going to take 1/4 and flip it upside down to multiply it. I'm rewriting this example a little further down so I can have more space to work. What I mean by multiply by the reciprocal, I'm going to take this fraction and I'm going to flip it upside down. 4/1. When you multiply fractions, you multiply straight across. So 4 times 1 is 4, and 1 times 4 is 4. Well, if you simplify 4 divided by 4, you get 1. When the numerator and the denominator of a fraction are exactly the same, it becomes positive 1. So that is how you cancel these out, and you're left with y. Remember the rule. What you do to one side, you have to do to the other. So if I multiply the left side by 4/1, then I need to multiply the right side by 4/1. Calculate, and you should get negative 32. And you can also plug this back into the equation to make sure your answer is right. 1/4, instead of putting y, I'm going to put times -32. Type that in the calculator or do it in your head, and you should get -8. Okay, last example. Example G. A little word problem. A zoo charges $12.50 per person. They made $675 in 1 hour. Write and solve an equation to find out how many people visited in that hour. X is going to be our unknown. What is the one thing we do not know? We don't know how many people. So X is going to equal the number of people. X is our variable, is going to represent what we don't know, which is the number of people. We do know that they multiplied $12.50 for each person that walks through the door. So that is $12.50 times X number of people. And that equals a total of $675. So there's my equation. $12.50 times each person, the X represents each person, equals $675. So now I'm going to solve this equation and ask myself the same questions. What is happening to the variable? Here's my variable. They're being multiplied. So in order to get my variable by itself and solve for the number of people, I need to divide by $12.50. What you do to one side, you have to do to the other side. And I'm left with X equals, and we want to calculate 675 divided by $12.50. And you should have gotten 54. 54 what? People. When it says how many people visited in that hour, 54 people visited in that hour. And you can plug that 54 back in, multiply it by $12.50, and you should get $675.